Hi. Yesterday we start solving exercise about logarithm, and we have stopped at part 4. Now we are going to continue part 4. Prove that f prime x equal gx over x cubed and study the sense of variations of f. Show that f prime x equal gx over x cubed. So here part 4. fx equal x plus 1 plus x plus ln x over x square. F prime x, derivative of x is 1. Derivative of 1 is 0. This one is u over v of the form u over v. This is u. And that one is v. U prime is 1 plus 1 over x into v, which is x squared, minus v prime 2x into x plus ln x over v squared becomes x power 4. So it will be 1, we expand, x squared plus x minus 2x squared minus 2x ln x over x power 4. It will be 1 minus x squared plus x minus 2x ln x over x power 4. We take x common and we simplify. It becomes minus x plus 1 minus 2 ln x over x cubed. We take the common denominator, x cubed minus x plus 1 minus 2 ln x over x cubed, which is equal gx over x cubed. F prime x equal gx over x cubed. Means f prime x has the same sign as g. But here gx is positive. So means f prime x is positive. So f prime has the same sign as g. Since g is positive, then f prime is positive. So it is increasing. At 0, we get minus infinity. And at plus infinity, we get plus infinity. And deduce that there exists a real number beta such that f of beta equal to 0. F of beta is 0. And beta between 0.46 and 0.47. It is easy, this one. F is continuous and strictly increasing. And we determine f of 0.46 and f of 0.47. So here, f is continuous and strictly increasing. It is proved. It is increasing over 0.46, 0.47. F of 0.46 is negative 0.035, which is negative. F of 0.47 is positive. It means that the equation fx equal to 0 has one root beta, and beta is between 0.46 and 0.47. Part B, write the equation of the tangent T to C at point with abscissa 1 and deduce the position between T and delta. Deduce the position between T and delta. So the equation of the tangent, you know that y minus ya equals slope into x minus xa. Now, xa is 1. We find ya, f of 1 equals 1 plus 1 plus 1 plus ln 1 over 1. Ln 1 is 0. We get 3. And the point will be 1, 3. F prime of 1, to find the slope, we get 1 minus 1 plus 1 minus 2 ln 1 over 1. We get 1. Then the equation of the tangent will be y minus ya, which is the 3, equals slope 1 into x minus 1. We get y equals x plus 2. Part C, and we need to study the position between the tangent and delta. Here I didn't study the position, but to study the position, we find fx minus y delta. If we find fx minus y delta, or y tangent, equal x plus 1 plus x plus ln x over x squared minus x minus 2, we get minus 1 plus x plus ln x over x squared. We need the position between t and delta, not between t and c, between t and delta. Here are not required.
Faster?
Yes. Position between t and delta. Since t and delta have the same slope, then we say that they are parallel. Slopelet tangent equals slopelet delta. Slopelet tangent equals slopelet delta equals 1, means tangent parallel at delta. Now to draw. Here, to draw, first we have to draw the oblique asymptote. The oblique asymptote y equal x plus 1. Y equal x plus 1, the oblique asymptote. For x equal 0, y equal 1. For x equal 1, y equal minus 1. This is the asymptote. Now the tangent at the point 1, 3, this is the point 1, 3. The tangent is parallel, or we can take particular points. So this is the point of tangency 1, 3. This is beta. This is beta. The curve is increasing from 0 minus infinity. It cuts the x-axis at beta. This is beta. Then it makes a tangent at this point. Then it goes near the oblique asymptote delta. Six. 6, we have capital Fx equal -1 minus ln x over x. Prove that f prime x equals ln x over x squared. Simply, this is u على v, u prime v minus v prime u over v squared. So f prime x, u prime is -1 over x times x minus v prime. It becomes minus into -1 minus ln x. It becomes 1 plus ln x over x squared. It will be ln x over x squared. Now deduce the antiderivative of fx. Deduce the antiderivative of fx. The antiderivative of fx هي antiderivative لx plus 1 plus x plus ln x over x squared dx equal x plus 1. I can split this one. I can put it x over x squared, which is 1 over x, plus ln x over x squared dx. Once again, it is x plus 1 over x. Ln x over x squared is f prime x. Now, x, the integral of x, it should be x squared over 2 plus x plus ln x plus الantiderivative del fx, antiderivative del f prime is fx. It will be x squared over 2 plus x plus ln x plus -1 minus ln x over x. Calculate the area of the domain bounded by C delta and the two lines x equal alpha and x equal 1. X equal alpha and x equals 1. This is x equal alpha. This is x equal 1. We need to calculate this area. The area between the curve and the oblique asymptote. The area between the curve and the oblique asymptote is the integral from alpha to 1 fx minus yd. Fx minus yd dx. The area the integral from alpha to 1 fx minus yd dx. The fx minus y delta we get x plus ln x over x squared dx. I split it, it becomes x over x squared. It becomes x over x squared. It will become 1 over x. This is not correct, please. X 1 over x plus ln x over x squared. This is 1 over x between alpha and 1. It will be this one ln x, not x, ln x. The antiderivative of f prime is fx. This one will be ln x minus 1 minus ln x between 1 and alpha. It will be ln 1. This one ln alpha. It will be ln 1 minus -1. We put instead of x ln 1 minus 1 over 1 minus ln alpha into -1 minus ln alpha over alpha. It will becomes ln 1 is 0 minus 1. So this is not correct. It will be equals -1 minus ln alpha minus 1 minus ln alpha plus 1 plus ln alpha over alpha units square يعني times 2 centimeter square equals minus alpha minus ln alpha plus 1. This one will be alpha ln alpha. Oh, not necessary خالص. Times 2 centimeter square. This is all about this exercise. We start solving another exercise. Exponential. Exercise 1. We have the function g defined on minus infinity plus infinity. We have the function g defined on minus infinity plus infinity as gx equal ax plus b into 1 plus ex plus e, where a, b, and c are three real constants. Ax plus b into 1 plus e to the x. Let g be the representative curve of this function. G cuts the x-axis at O. G cuts the x-axis at O here. G passes through the point minus 2 minus 4 here. This is minus 2 minus 4. Minus 2 minus 4. This is 2 minus 4. And the line y equal minus x minus 2 is an asymptote to g at minus infinity. Calculate g of 0. G of 0 equals 0. You know, it passes by the point, so g of 0 equals 0. G prime of 0 is also 0 because the g prime of 0 is the slope of the tangent at O. And at O, x prime x is the tangent, so g prime of 0 equal to 0. G of 2 equal minus 4. So g of 0 here, g of 0 equal to 0. G prime of 0 equal to 0, as I told you, because the x-axis is tangent to the curve at O, and g of 2 is equal to minus 4. Part 2, we need to calculate A, B, and C. So here we have three conditions. We use three conditions in order to calculate the three unknowns. G of 0 equal to 0 means A times 0, 0, 0 plus B into 1 plus e to the 0, e to the 0, 1 into 1 plus 1 plus c equal to 0. We get 2b plus c equal to 0. This is the first equation. Now, g prime of x, u dot v. To calculate the derivative of u dot v, it is u prime, g prime x equal, u prime is a into 1 plus e to the x, a into 1 plus e to the x, plus e to the x into ax plus b. After taking ex common, we get a plus ax plus b plus a e to the x. G prime of 0 equal to 0 means a into b plus a equal 0 means 2a plus b equal to 0. The third equation, g of 2 equal 4 means 2a plus b 1 plus e squared plus c equal minus 4. Now 2a plus b is 0 from 2. 2a plus b is 0. So we get 0 times 1 plus e squared. We get c equal minus 4. C equal minus 4. Now we can calculate b. B will be equal to 2. After calculating b, we can calculate a. A will be equal minus 1. Exercise 2. Exercise 2, part A. Consider the function g defined over R by gx equal 1 minus x e to the power x minus 2. Draw the table of variations of the function g. So I have to calculate g prime. Derivative del minus x is minus 1. Derivative del e to the u is u prime, yani is e to the x minus 2. So g prime x, derivative del minus x is minus 1. Derivative del ex minus 2 is e to the x minus 2. G prime x equal to 0 means e to the x minus 2 equals 1. Ln the two sides, then x minus 2 equal ln 1, which is 0, then x equal 2. Table of variations. Table of variations, this is not 0, this is will be 2. Table of variations, x, g prime x, gx, minus infinity plus infinity. At 2, the derivative is 0. If we take a value less than 2, like 0, and we replace it in the derivative, we get minus 1 plus e to the minus 2, which is negative, and this one will be positive. Negative decreasing, positive, it means increasing. Now, f of 0, g of 2, it will be 1 minus 2 plus 1, we will get 0. Limit al plus infinity equal minus infinity plus infinity. We take the limit of the highest power, we get plus infinity. Limit al minus infinity, this one 0, we get plus infinity. Not necessary to determine the limits. Now show that for every real number, gx is greater than or equal to 0. Since the minimum is equal to 0, minimum of gx, so show that for every real number, gx greater or equal to 0. Since the minimum of gx is 0, then gx is greater than or equal to 0. Part B. Part B, we have the function fx equals x minus 1 plus x e power 2 minus x. will f and the curve and see here representative curve of f. Part 1, limit at minus infinity. Part 1, limit at minus infinity. We replace x by minus infinity. It will become minus infinity minus 1 is minus infinity this x times plus infinity e to the plus minus minus بصير plus بصير plus infinity times minus infinity بصير minus infinity. So we get minus infinity. Now limit as x tends to plus infinity. This one becomes plus infinity. Plus infinity times 0 indeterminate. بننزل exponential لتحت. بتصير x. This is not correct. It will be x over e power x minus 2. We apply Hospital's rule. It will be limit as x tends to plus infinity. X minus 1 plus x is 1. E to the x minus 2 is derivative is e to the x minus 2. This one will be 0. The limit will be plus infinity. Part 2a. Show that the line delta of equation y equal x minus 1 is an asymptote. Here I have to, which infinity will make this limit 0, plus infinity or minus infinity. So I take the limit fx minus y as x tends to plus infinity equal limit as x tends to plus infinity of x e to the power 2 minus x. It will be infinity times 0 indeterminate. بننزل exponential لتحت x over e power x minus 2. Hospital's rule, we will get 1 over e power x minus 2 limit will be 0. Then the line delta of equation y equal x minus 1 is an oblique asymptote to c at plus infinity. Now study the relative positions between c and delta. To study the position, fx minus y is equal x e power 2 minus x. If we solve it equal to 0, x e power 2 minus x equal to 0 means x equals 0. Table minus infinity plus infinity 0. It will fx minus y is 0 at 0. X before 0 is negative, positive here. Negative, we say c is below delta. Positive, c is above d or delta. Here means d cuts delta at the point 0 minus 1. At the point 0 minus 1. Part 3. Show that f prime x equal e to the power 2 minus x times gx and set up the table of variations. F prime x equals 1 plus e power 2 minus x e power 2 minus x. Let's take e power 2 minus x times gx. it will be e to the power 2 minus x into gx is 1 minus x plus e power x minus 2. E power 2 minus x, if we expand, minus x e power minus 2x. E power 2 minus x times e to the power x minus 2, it will become e to the 0, which is 1. So they are equal, means f prime has the same sign as g. F prime x has the same sign as gx, but from here gx is greater than or equal to 0, means f prime x is greater than or equal to 0. So minus infinity plus infinity. So here, f prime x, fx, it is increasing, it is positive, 1 positive. So it is increasing here. From al minus infinity we get minus infinity, al plus infinity we get plus infinity. This tool انه على 2 بتكون الديريفاتيف الاف برايم بتكون الجي اكس 0 in الاف برايم 0. Not necessary to write this term. Part 4. Show that the equation fx equals 0 has a unique root alpha between 0.1 and 0.2. So f is continuous and strictly increasing. F is continuous and strictly increasing. Then C cuts the x-axis. So fx equal to 0 has one solution alpha. F of 0.1 is minus 0.23, which is negative. F of 0.2 is 0.4, which is positive. Means alpha is between 0.1 and 0.2. Part B, solve the inequality. Solve the inequality e to the power 2 minus x greater than or equal 1 minus x over x. We bring them to one side. So x e power 2 minus x greater than or equal 1 minus x. So x e power 2 minus x minus 1 plus x greater than or equal to 0 means fx greater than 0. Fx greater than 0, since the function is increasing, al alpha it is 0, so fx greater than 0 if x greater than alpha. Fx greater than or equal to 0 in x belongs to alpha plus infinity. Part 5. Determine the point I where the tangent t to the curve is parallel to delta. Two lines are parallel if and only if they have the same slope. Slope للتangent هو ال f prime x. Slope للدلتا is equal to 1. Slope للتangent equal slope للدلتا equals 1. F prime x is 1 plus e power 2 minus x e power minus 2 minus x equal 1. 1 and 1 simplified. We take e power 2 minus x common into 1 minus x equal to 0. So x equal 1. To find the value of the ordinate, we calculate f of 1. f of 1 is 1 minus 1, 0. بتصير e to the 1, which is e. We get the point I 1e. Draw delta, tangent, and C. Delta y equals x minus 1 is an x0, y minus 1 is an x1, y0. This is the line delta. The tangent at the point 1e, this is the point 1e, 12.7. This is A. And we draw the tangent which is parallel to delta. We can take some particular points. At x equal to 0, y is equal to minus 1. At x equal minus 1, we find the value of y. The function is increasing, makes a tangent at the point 1e, then it goes near the oblique asymptote. The last part, 7, discuss according to the values of the real parameter m, the number of solutions of the equation fx equal x plus m. The line y equal x plus m is a line parallel to the tangent or parallel to delta. If m equals e minus 1, we have one solution. If m equal e minus 1, we have one solution. If m between 1 and e minus 1, if m is between 1 and e minus 1, we get one solution. Here we have one solution. If m, we have two solutions, afwan. And if m is between, if m greater than e minus 1, we have no solution. This is m greater than e minus 1 here, no solution. Here, also we have one solution. If m here, also we have one solution. If m less than minus 1, we have one solution. This is all about this exercise. Write the notes on your copybook.